Okay, so think about all those real-time interactions you have online pretty much every day. We're talking like chat apps buzzing, live updates scrolling down your feeds, maybe collaborative docs where you can actually see someone else typing right then. How does all that actually happen? These back and forth conversations that just flow without you constantly hitting refresh or your browser making like a whole new request for every tiny bit of data. Well, the secret, as you might guess, it's definitely not your standard HTTP.
Yeah, you've really hit on a core challenge of the modern web, haven't you? So today, our deep dive is all about WebSockets. We're going to unpack the actual code for a Python-based WebSocket Echo server and, the client that talks to it.
Right. And our mission here is to take this source material, the code you've got, and really break down how these bits work together. We want to demystify some of that magic behind real-time stuff. So by the end of this, you should have a really clear understanding of the main ideas, the key Python libraries involved, and just how the information flows to make these persistent connections actually work. Okay, let's get into it.
Yeah, and what's really interesting here is just how different it is from the way the web usually works. So HTTP, which most people know, it kind of works on this request-response model. Your browser asks for something, the server sends it back, and then typically the connection is just dropped. Done. It's a bit like, I don't know, making a phone call where you hang up after every single sentence, even if you want to immediately say something else.
Right. Exactly. And it's not just the hanging up, is it? It's the overhead of dialing again, setting up that connection every single time, maybe just for a tiny update. WebSockets completely changed that. They set up this persistent two-way communication channel all over a single connection. Once that's open, data can just flow back and forth immediately, super low latency. It really makes things feel, live, turns static pages into something dynamic.
And if you think about the bigger picture, this ability to have an always-on conversation is, well, it's absolutely critical for so many modern apps. Think about online games or live sports scores updating instantly, or those collaborative tools you mentioned earlier. HTTP just wasn't built for that kind of constant chatter. It'd be, frankly, incredibly inefficient.
Okay, so to actually build this kind of real-time system in Python, you mentioned there are two really essential libraries, Asyncio and WebSockets. Now, WebSockets, that name makes sense, right? It handles the WebSocket protocol. But Asyncio, why is that so crucial here? What problem is it solving that maybe a simpler approach wouldn't handle?
Yeah, that's a great question because it's often the bit that trips people up. You might think, oh, well, just handle one connection, then the next. But what happens when you've got hundreds, maybe thousands of users all trying to connect at once? Asyncio gives you the asynchronous framework. That's the key. It lets the server handle lots of client connections at the same time, concurrently, without getting blocked. So your server isn't stuck talking to just one person while everyone else is waiting. It's juggling all these conversations efficiently, making sure everyone gets a response.
Okay, juggling conversations. I like that. And you mentioned coroutines are involved.
Right. And for anyone less familiar, a coroutine is basically a function that can pause itself, let other things run, and then just pick up right where it left off. It's super efficient for managing lots of connections that might be idle most of the time, but need instant responses when something does happen.
Got it. So Asyncio manages the juggling. Now let's look at the actual server code. The core seems to be this function called echo. The code shows async def echo WebSocket. So, okay, it's an async function, a core routine. It handles a client. But how does just one function definition handle maybe hundreds of different clients? What's that WebSocket parameter really representing?
Ah, yeah, that's the clever part. That WebSocket parameter isn't generic. It is the actual unique connection, the communication channel for one specific client that just connected. So basically, every time a new client connects, the server starts up a brand new separate instance of that echo coroutine just for them.
Oh, interesting. So each client gets its own little dedicated handler running.
Exactly. And that's not just, neat code. It's fundamental to how things like massive chat apps or big online games can actually work. It's how they scale to handle potentially millions of users all talking at once without the whole system just, collapsing. It's the secret sauce, really.
Okay, that makes sense. And inside that echo function, I see this try, except websockets.exceptions.connection block. Why is that important? What's its job?
Well, it's basically like a safety net. You need it for robustness. Things go wrong online.
Right.
Clients disconnect suddenly. Maybe they close their browser, lose internet. That block is there to catch that specific connection closed error gracefully. So instead of the whole server crashing because one client disappeared, it just handles that specific disconnection, maybe logs a message, and then crucially keeps running to serve all the other connected clients.
Right, keeps the server stable. Okay, now digging deeper into Echo, there's this loop. Async for message in WebSocket. That async for looks different from a standard loop. Why is that specific syntax so important for handling these real-time messages?
Absolutely. That async for is where the magic of receiving happens continuously. It tells the server to just, well, listen for incoming messages on that specific client's connection. But the async part is key. It means while it's listening or waiting for a message from this client, it doesn't block everything else. If no message arrives right away, the server can pause this core routine and go do work for other clients. Then, when a message does arrive for this client, it comes back and processes it. It's how you efficiently manage lots of connections that might be sending messages at unpredictable times.
Okay, so it listens patiently without stopping everything else. And when a message does arrive, the code shows it prints the message and then sends it back using await WebSocket.send f echo.message. There's that await keyword again. Why is await needed when sending the message back?
Good catch. The await there is also crucial. It tells this specific echo routine to pause its own execution until that send operation is fully completed. You want to make sure the message has actually gone out over the network before you, say, try to listen for the next message from that client. It keeps the conversation orderly for that specific client-server pair, ensures things happen in the right sequence.
Got it. Order matters. Okay, moving away from the handler itself, let's look at the server setup in the async def main function. This seems to be the main starting point that gets everything running.
That's right. And the absolute key line in main is this one: async with WebSockets.serve, echo localhost 8765. This is what actually creates and starts the WebSocket server. You can see it's configured to use our echo function as the handler for any new connection. It's told to listen on localhost, which just means connections from the same machine for this simple example, not the whole internet, and it's using port 8765. The async with part is important too. It's Python's way of making sure that when the server eventually stops, all the resources, like network sockets, get cleaned up properly.
And then there's a simple print message. Print WebSocket server started. Just confirming it's up. But then we hit this slightly weird line. Await Ascencio future. Hashtag run forever. That looks odd. What's a future doing there, and how does it make the server run forever?
Yeah, it's actually a pretty clever trick used often with Ascencio. And Ascencio future is like a placeholder for a result that doesn't exist yet. By just creating one and awaiting it without ever setting a result for it, you essentially create a task that never finishes. It basically tells the Ascencio event loop, the thing managing all the asynchronous tasks, hey, I'm waiting for something that will never happen, so just keep running everything else indefinitely. It's a neat way to prevent the main server script from just ending immediately after starting the server.
Huh. Okay, never-ending placeholder, clever. And the very last bit is standard Python stuff. If name equals main, ascencio.run main, which just means if I run the script directly, start the main function using Ascencio.
Exactly. That kicks the whole server process off.
Okay, so that covers the server. Makes sense. But that's only half the story, right? How does a client actually connect and talk to this thing?
Right. You need the other side of the conversation. So let's look at the client code. Unsurprisingly, the client also needs to import Ascencio and WebSockets.
And its main logic seems to be in another async function, async def send messages. First thing it does is define the server address, URI ws.localhost 8765. That tells it where to connect. Then the line async with WebSockets.connect, URI. That must be where the actual connection happens. I guess connect does a lot behind the scenes.
Oh, absolutely. Yeah. Establishing a WebSocket connection isn't just opening a socket. There's a specific back and forth, a handshake, that has to happen first to upgrade the connection from HTTP to WebSocket. But the beauty of the WebSockets library is that WebSockets.connect handles all that handshake complexity for you. You just give it the address.
Nice. So once it's connected, it prints a message like connected, type exit to quit, and then enters a wild tree loop. It looks like this makes it interactive.
Exactly. That loop is the heart of the client's interaction. Inside, it uses Python's basic input function to prompt the user to type something in the console.
Okay, so the user types a message. If they type exit, if msg.lower, its exit.breakline just stops the loop and the program ends. Simple enough. But if they type something else, like hello, it sends it off with await WebSocket.send, msg, and then crucially, it immediately does response await WebSocket.recv. Why does the client have to explicitly await that response? Why not just send messages faster?
Because this is an echo server interaction we've set up. The whole point is the back and forth. That await WebSocket.recv tells the client program, okay, pause right here. Don't ask for more input. Don't do anything else. Just wait until you receive a message back from the server.
Hmm.
In our case, it's waiting for that echo.hello response. Without that await, the client might loop back immediately, ask for new input, maybe even send another message before the echo for the first one even arrived. That would break the conversational flow. It keeps the client and server in sync for this turn-based chat.
Right. It enforces the send, wait, receive, print cycle, makes the interaction predictable, and then it just prints the receives response and the while loop continues asking for the next message.
Precisely. It demonstrates that persistent two-way street really clearly. You send, server receives, server sends back, client receives, all over that one open connection.
Yeah.
And then finally, just like the server, the client script is started with asyncio.run, send messages.
Okay, so let's sort of wrap this up. What have we really seen here? We've basically walked through a simple but complete WebSocket server and client using Python. We saw how Asyncio is the engine that lets the server juggle lots of clients simultaneously, keeping things responsive. And we saw how the WebSockets library takes care of the protocol details, making it relatively easy to set up this persistent two-way communication, which is a huge step beyond the old request response world of plain HTTP.
Exactly. And now that you've got a handle on the basic mechanics of this Echo server, it made me think about this. What other web features, things you use every day, rely on this kind of instant back and forth communication? Things like editing documents together online in real time, maybe multiplayer games, those livestock tickers or sports scores. Chances are, underneath the hood, they're built on these very same principles. WebSockets are really fundamental to how the interactive real-time web actually works today. Understanding this simple Echo example is, well, it's key to grasping all that.